All right. Good afternoon, everybody, and welcome to part 15 of the Artificial Intelligence course. And we're in Unit 3 still, and we're looking at AI usage and prompt engineering. And today, what we're going to look at is advanced prompt engineering. Let's get started. All right, so when we're looking at advanced prompt engineering, we've already looked at the 5 phases of prompt engineering in the previous parts of this unit. We've built up a basic framework to write an effective prompt. We've looked at the task and how action words and being clear and specific and having a defined and measurable goal is really the part of the prompt that focuses on the initial and the important task. We've looked at context and how we can define a source or a speaker or the who. And we can define a target or an audience or the whom. And we can define things like tone and style and perspective to give context. We've looked at constraints, like things like scope and format, and how we can have an open-ended versus a close-ended prompt. We've looked at types like length and audience and persona and structure, exclusion and syntactic and positional constraints. And we've looked at advanced constraint techniques like chain of thoughts and tree of thoughts. We've looked at examples and how you can use examples like zero-shot prompting with no examples, one-shot prompting with one example, or few-shot prompting with many examples. How we can have input-output pairing and template examples, or even multimodal reference examples to improve our prompts. And finally, we've looked at the iterative phase, how we can fix the prompt, how we can respond to the output from a prompt, how we can write shorter sentences and different phrasing, and revisit this 5 phase framework, how we can leverage one AI versus another AI, do even advanced techniques like meta prompting and applying role play like an AI agent, and even prompt chaining. This is all one big suggestion in prompt engineering. You really don't have to use all 5 phases every time you write a prompt. That might be overdoing it. It's one possible framework to keep in mind. You don't have to apply all those areas. Keep the overall framework in mind as you engineer your prompts. But today, we're going to dive into more advanced and technical aspects of prompt engineering. So one thing to keep in mind is despite AI's impressive technology, prompts and outputs are not immune from the errors that come up in AI. So here's look at 2 big examples. The first is hallucinations. This is when the AI generates plausible sounding, but false and misleading or even nonsensical information, but it presents it to you as fact. Common with a lot of large language models that make up things based on the training data rather than going out and retrieving accurate factual information. The other big thing is biases. This is when the AI produces results that are systematically unfair. They're prejudiced, they're discriminatory against certain groups or individuals. This reflects the underlying training data that it was trained on or the way the AI model was designed. So this can include data bias, the bias in the training data, or algorithmic bias, when the bias is introduced during the design, the implementation, or the deployment of that AI model. All right, so let's move next to a fancy, more advanced thing called retrieval augmented generation, or simply put, RAG. So standard prompting works with what the model already knows. That's what the training data is used for to train the model, and it bases its responses on that training data. But one other technique is retrieval augmented generation, or RAG. RAG is a technique where you feed the AI a document or a database at the time of the prompt and ask it to answer only from that material, not from its training data. So, for example, using only the following passage, answer the question. Do not use any prior knowledge. If the answer is not in the passage, say not found. And for that, you would either copy and paste a passage into your prompt or multimodal attach something like a Word document or even a link to the passage itself. This is how AI tools like law firms and medical records and enterprise searches work. RAG is essentially a context injection strategy. So we're injecting a context directly into the prompt. RAG determines what goes into the context, but prompt engineering determines how the model is told how to use it. So we use the two working together. RAG, the basic workflow for RAG is: one, the user submits a query or a prompt. Two, the system will now search a database or a specific document collection for the relevant information. It does not go into training data. The retrieved content is then injected into the prompt as the context, as part of that prompt engineering. AI will then generate a response based on both the query, in other words, the prompt we wrote, and the retrieved material. The retrieved material augments the output that it generates. Without RAG, a model is limited to what it learned during its training data, which is a lot, but it can't access any new information, any private documents, or anything beyond its data itself. That cuts off its knowledge base. RAG solves this by connecting the model to live or curated data sources at the moment of your inference. This matters because LLMs alone forget recent events. They hallucinate, like we mentioned. They cannot reliably access private data. Imagine, for example, as an analogy, asking someone a question, but before they answer, they get to flip through a relevant textbook. RAG is the act of handing them the right pages, and prompt engineering is giving them the right instruction about how to use those pages when they form their answer. RAG fixes all of this by grounding the responses in retrieved documents. Here's another way you could look at it. The user asks a question, the retriever searches the document, relevant chunks are selected from that document, and the LLM answers using the chunks it retrieved from the document. There's an important distinction here with RAG, though. There's RAG at a technical level versus what you can do when you are using a chatbot and keeping RAG in mind. So a manual RAG is kind of what we've been describing. This is what you do in chatbots like Claude or ChatGPT or Gemini. When you do that multimodal prompting and attach the source material yourself, or give a specific example and constrain the AI to use only that material. So this is two-part. One is you are using the example, right? But the other part, the first part, is your prompting pattern. It might look something like this: using only the information in the document I've attached. Answer the following question. Then you provide the question. Do not use any outside knowledge. If the answer is not in the document, tell me or say not found in the provided material. Okay? Or maybe you have pasted text. Here is a passage. You paste in the text. Answer the following question using only this passage. Quote the specific sentence that supports your answer. If the package does not contain the answer, say so explicitly. The key prompt engineering move here is we are explicitly defining the source with wording like only the information in ... Two, we are excluding outside knowledge. We're asking it through our prompt, do not use any outside knowledge. Three, we're building in an honest failsafe. We're saying things like, if the answer is not found, say so, avoiding the hallucination factor by making it, if it doesn't know, it tells us it doesn't know. Without it, the AI will often blend that provided material with its training data and can't tell you which is which, and it won't tell you if it can't find it within the source material. But at a deeper level, RAG is a software architecture, not just a prompting technique. So RAG, when we have a document database, like a company's internal files, where we have a search and retrieval system that goes and finds those relative chunks when the users of that system ask a question, and those chunks are automatically injected into the prompt. The AI will answer based on those chunks. So this is a RAG system built using AI, but certainly building it to go beyond training data and only within the document database of, say, a company itself. This is how a lot of AI tools, like, for example, Notebook LM or enterprise chatbots or AI powered searches within organizations actually work. The RAG keeps it within the source material. The user asks a question, they never see that retrieval step happening, but that's what RAG is doing. So here's an example. If we have no RAG, what causes inflation? Okay. Versus RAG, where we say, I'm attaching a passage from an economics textbook. Using only this package, explain what causes inflation in your own words. If the passage does not give a complete answer, say what's missing rather than filling in the gap yourself. In that second RAG style version, we're using and we're also demonstrating and teaching a critical thinking habit alongside of the specific prompt engineering skill. The AI's job is to be a faithful interpreter of the source, not making up free range knowledge. And this is important for students to realize too. When you are working in academia and when you're writing papers, stick to the source material. Don't just make up facts. All right, let's move on to another advanced prompt engineering skill, the structured prompting using XML. So as prompts grow more complex, containing multiple inputs, multiple roles, instructions, and examples all at once, paragraphs can start to blur together as you write a longer and longer prompt. And the AI might struggle to identify which part of your prompt message is the instruction versus the data versus the example. Think of it like the difference between handing someone a page of plain text and handing them text that's labeled, or a form that's labeled with each section labeled out. The information might be identical in both pages, but the form tells you exactly where to look and what section each section means. One way to do this with prompt engineering is to add and use XML tags. So XML, standing for Extendable Markup Language, is a formatting system that uses what are called opening and closing labels called tags to mark up sections of text. If you think back traditionally, this is like you using a highlighter to mark something on a piece of traditional paper. You may have seen this in web pages. HTML is an early version of what XML is. It uses the same idea. You can also see this if you have any exposure to things like computer code. In prompt engineering, you borrow this idea without really needing to know any programming or coding knowledge. Tags are plain text. You simply type them. They act as clear, unmistakable labels to tell the AI, to label the AI, what section your prompt represents. So how tags work is you use two, what we would call angle brackets, or the less than greater than sign. And then you put a word inside those angle brackets, and that is your opening tag. In other words, this is the start of the label. If you were using a highlighter, it's where you would put the highlighter pen on the piece of paper to start. And then you also have what's called a closing tag. So in other words, you would drag the highlighter up to a spot and you would lift it off the page. That's where it closes. So between opening and closing, you've labeled that section. With the closing tag, you're going to include the / character before the word itself. But we're going to look at some examples here. The basic syntax is opening tag with its name, and then all your content, and then closing tag. Okay. The opening tag starts with the angle bracket, the name, and the closing tag starts with the angle bracket and the / followed by the name. Everything in between those two tags is the content of the labeling section that you're applying this to. LLMs process your entire prompt as one stream of text, and the tags break that stream up into named containers, producing a lot of benefits. So without the XML tags, the AI must infer what each paragraphs mean. Oh, is this the specific example, or is this the example? Is this my initial prompt directive, or is this my prompt directive? Each section with tags is explicitly labeled. No more guessing by the AI. Instructions and data can blur together without XML tags, but with the tags, the AI knows instantly, this is my data, this is my instruction. Without the XML tags, examples might look like instructions to the model. But with tags like, for example, the tag example or the tag instruction, this is no longer ambiguous. This is now unambiguous. Without the tags, outputs are inconsistent when prompts are reused. But with tags, tag prompts produce reproducible and predictable outputs. And without tags, long prompts are really hard to read, and they're hard to figure out where you went wrong or to debug. But with the tags, now our tags make our prompt easier to review, easier to revise, and I would even say easier to repeat. Here's an example of a tag prompt and how it might be structured for a complex tag. So this is a direct screen capture from Claude, where I've put a tag that says role, and then at the end, a closing tag for role. In between is the content. You are an experienced science teacher of grade 10 students. The role is defined. Then you can see other tags like context, constraints, output format, all with an opening tag and a closing tag. These tag names work because they're descriptive. Role, task, context, constraints, output format. They're clear English words that the model understands and uses as labels for each type of content. So you can name tags literally anything. You don't have to memorize a bunch of name tags, but there are some common ones. So I've presented them in this table here. These are ones that are widely used and well understood. So a tag name like role or persona, it contains who the AI should be. And for example, you could use it to assign a teacher or lawyer or journalist persona to the tag or to the prompt. A tag name like task contains the core instruction. And for example, it gives the main action word prompt. A tag like context gives you background information. It provides setting, audience, and purpose. A tag like constraints gives you rules and limits, and it's used for length and format and exclusions. Tag like example or examples, don't have to be specific, provides you with sample input-output pairs, and it can be used for few-shot demonstrations. Tags like input or data give you raw material to process, and it can be used for paragraphs to summarize or code to debug. Tags like output underscore format provide the shape of the expected answer, and they can be used to create tables or bulleted lists or numbered steps. And a tag like instructions can provide step-by-step directions and can be used to provide multi-step breakdowns. Tags like document give you a longer piece of text and can be used for essays or articles or reference. And finally, a tag like thinking can essentially contain reasoning scratch spaces to the AI. And what it does is it asks the AI to reason before answering, and it might even show you the steps of reasoning, depending on the model. So XML tags keep your data, that content you want processed, cleanly separated from your instructions, what to do with it. And without the tags, the AI has to guess which is which. So without tags, we're in an ambiguous space. So for example, here is the student essay. The French Revolution began in 1789 and was caused by the financial crisis and social inequality. Summarize it in 3 bullet points and identify any factual errors. But with tags, it's less ambiguous or it's unambiguous. So we provide an opening tag, document. The French Revolution began in 1789 and was caused by the financial crisis and social inequality. Close the document tag. Open a tag, task. Summarize the document in 3 bullet points and identify any factual errors. Close the task tag. Now the AI has 2 very clear labels. What is the document and what is the tag? So this matters. In the untagged version, the AI could potentially treat the essay as part of the instruction or include instructional language in the summary. But tags eliminate that ambiguity entirely. XML tags can be also nested inside of each other to get even more complicated, but also more powerful. To organize complex prompts with multiple examples or multi-part inputs. This is especially useful for few-shot prompting. So if you look at this screen capture from the DeepSync, or from the AI prompting itself, we have the outer examples tag, and then nested within that tag, we have input and output tags nested within example. Okay, this is like a container inside of a container, very much like the Russian doll analogy we used back in the first unit. These tags make the pattern very clear. No description is needed. The structure shows the relationship. So you can see by that structured prompt, we get a very specific output. Simple sentence, past tense, past perfect tense, passive voice. We get we've distilled down the exact output we wanted. You can use XML tags in reverse as well. We can ask the AI to produce output in XML tag sections. This is useful when you need specifically extracted sections. From a practical standpoint, when you ask the AI to structure its output with tags, you can copy specific sections, for example, just a recommendation tag section, without having to reread the entire response. It also makes comparison across multiple outputs much, much easier. So let's look at that example. If we say analyze the short story The Monkey's Paw by W.W. Jacobs and respond using these tags. Theme, your analysis of the central theme, close the theme tag. Conflict, describe the main conflict, close the conflict tag. Tone, describe the emotional tone. And recommendation, would you recommend this for grade 11? And frame the entire output in under 100 words. So you can see the output I got there. I got the theme clearly identified. I got the conflict and the tone clearly identified. And my recommendation labeled section is clearly identified. I now have an output that I don't have to sort through to figure out what is what. It is framed and labeled the output using XML tag structures. All right. Another really advanced way to look at prompting is using something called a slash command. So what's a slash command? So it's going to look like this. It's going to once again use that / character followed by a command word. We usually call this slash command. It's short for an instruction that begins with that / character. You type it directly in your prompt, usually on its own line at the start or end of a prompt message. And the AI treats it as a special directive rather than conversational text. It's like you're clicking a button in the AI prompt that does a specific task. This idea came from traditions like chat apps like Discord or Slack, where that slash command trigger, you might recognize, will trigger built-in features. It's also useful in programming terminals like the command line, where typed commands execute specific actions. So in the context of AI prompting, slash commands have evolved into shorthand vocabulary, or kind of like cheat codes, a way to communicate intent in a single compact token rather than writing it out in a full sentence. So there are many popular AI chatbots and tools that support a range of those slash commands. So here are some examples that are pretty commonly supported. Slash summarize, summarizes a current conversation document or selected test. Slash explain, explain something in simpler terms, often used with code. Slash fix or slash debug, fixes and finds errors, again, commonly in coding. Slash translate, and then you provide the language. We'll translate the text into a specific language. Slash shorten, we'll rewrite the current output in fewer words. Slash expand, which will elaborate on or add more detail to that current output. Slash format, and then you provide the style, which will reformat this response, like for example, into a bulleted list or a table. Slash tone, and then an adjective, which will rewrite it in a specific tone, like formal or casual, etc. Slash compare, where we compare two or more items side by side. Slash draft, which would produce a first draft. Slash revise, which would revise the current output with whatever changes we ask it to provide. Slash commands do vary platform to platform, so maybe check to make sure if you're going to use slash commands extensively, are they recognized by that AI? The use of slash commands after an output response as a follow-up in the conversation is much faster than rewriting your prompt. So let's look at an example. So let's say this is our first prompt. Explain how, and you can see this in the screen capture that I used. Explain how the judicial branch of government works. And we get a very detailed response. I didn't show all of the response there. It's way too long to show. My second prompt is just a slash command, slash shorten. And now we have a much shorter version. I still didn't include all of it because but it's much, much shorter. And then I provide another slash command, slash format bullet points. And now it took my shorter response and put the whole format of that into bullet points as a bulleted list. And now I provide another slash command, slash tone, grade 9 reading level. It went through and changed that shortened bullet point response by going through the vocabulary and the sentence structure and reformatting it to a grade 9 reading level format. Each slash command acts as a single turn refinement. Rather than repeating your whole prompt and adding more wording, the slash command is a power user way to operate on whatever the AI just produced. Many AI systems allow you to even define your own slash commands at the start of a conversation. You can see that in this screen capture. I wrote, for this conversation, interpret the following commands. And then I gave a list of slash commands. You can see the AI provided that it understood what those means. And now I can iterate off this prompt because once I've created a consistent shorthand vocabulary for a specific workflow, now it's defined. I can use those shorthands throughout the conversation with the LLM and speed up my tasks, So this is a form of context engineering, a more advanced sort of power user way to do it. So let's look at a summary of these advanced prompt engineering techniques I've introduced today. XML tags, role, task. What they do, they label and separate out sections of a prompt. When should I use it? When I have complex prompts with multiple components. Nested tags, those are group-related items. For example, multiple examples. When should I use that? Well, when few-shot prompting provides several examples. Output tags, where I ask the AI to tag its response, where it will structure the output for easy extraction. When should I use that? Well, when you need specific sections of an output response. And slash commands, the built-in slash commands, well, I know what it's gonna do is it's gonna give single token instructions to modify the output, and I wanna use it when I wanna make quick refinements in the iterative phase after a response. When should I define custom commands? When you want to build a shared vocabulary for a workflow with an LLM. We use it when we want repeated tasks within one conversation. Here's an example of combining multiple techniques. Notice how each element is doing a specific job. So we're going to look over on the screen capture, okay? I've asked it to define a role. Then I've asked it to define a context using XML tags, and then a task, and then the examples. But within the examples tag, XML tag, I've nested specific example, and I've nested an input, I've nested an output of a specific example. In theory, I could then nest another example as well. Then I provided a constraints tag, and then I provided an output format tag. So I'm using XML tagging, I'm using nested tagging, and I get my initial response. In my initial response, I then use a slash command, shorten, to shorten out that output down. So this single prompt used persona, background information, task, template example, a few shots, constraints, and custom output tags, okay, which I told it to define. I said, respond inside these tags, outline and teaching note. So I've outlined and asked for specific output tags and a structured output format. So I've combined a whole bunch of advanced techniques here to get each layer adds another level of precision to the specific output I got. And if you look, Copilot provided me a shortened output with a thesis and a description and a conclusion, and it's also provided the structured tagged output of a teaching note that I can use. This is power prompting. These advanced techniques add that power, but also ways that it could go wrong. So watch for these common mistakes. Forgetting a closing tag. For example, writing an opening tag task, but not the closing tag task with its forward slash in it. How should I fix that? Always make sure you have an opening and closing tag and that the closing tag has the slash at the beginning. Another mistake, using inconsistent tag names throughout a prompt. So pick a name and stick to it. Consistency helps the AI parse your prompt out correctly. It's a machine after all. Creating slash commands without defining them first, right? If you're going to use custom slash commands, define them early on. Don't assume the AI knows what something like slash quiz means. Another common mistake, mixing tags and plain paragraphs in a confusing order. Group all your tag sections together. Don't scatter the tags through running prose. And last, using too many tags in a single prompt. Reserve tags for complex multi-component prompts. Simple tasks, they don't need all this scaffolding to really identify what you're looking for. AI and LLMs are built for parsing your text. Thank you, everybody. That was a longer presentation, but I hope you found it very useful on advanced prompt engineering techniques. Have a great day.